Hello children, welcome to my channel. Today's topic is Rectilinear Figures Part 1, Chapter number 14 of Class 9, ICS. Okay, so let's start. The other name of rectilinear figure is polygon. Okay, you might have come across this term polygon in our lower class, maybe in class 6, 7 or 8 also. Polygon. First we will understand what a polygon is, then we will move into the chapter. Okay. So what is a polygon? It is a closed plane figure it is a closed plane figure bounded by line segments. These 2 points are very important for a polygon. Okay. First condition is it should be closed. Okay, it should be closed. The plane figure must be closed. The second condition is it should be bounded by line segments. If it doesn't satisfy any of the 2 conditions, then it is not a polygon. For example, see this. I have made the boundaries using line segments 1, 2, 3, 4. There are 4 line segments, but this is not closed. It is not satisfying the first condition, so this is not a polygon. Okay, this is closed. It is satisfying the first condition, but its boundaries are not made of line segments. As you can see, this is not line segment. So this is also not a polygon. See this. This is closed. First condition is satisfied, but second condition is not satisfied. 4 of its boundaries 1, 2, 3, 4. 4 are made of line segments, but this one is not a line segment. So this is also not a polygon. Okay. So 2 conditions have to be satisfied. This can be a polygon. You can see it is closed and it is bounded by line segments only. So this is a polygon. But you are familiar with this figure. This is called a triangle. So remember, every triangle is a polygon. Okay. Every triangle is a polygon. In fact, the polygon having minimum number of sides is a triangle. Next we can have 4 sides. Okay, it is also a polygon. Its special name is quadrilateral. Quad means 4. Quad means 4. Okay, so its special name is quadrilateral. So every quadrilateral is also a polygon. In this chapter, we will be studying in detail about some specific types of quadrilaterals. Okay, I will move to it later on. Next we can have 5 sides. 5 sides. It is also a polygon. Its special name is Pentagon. Pent means 5. Pent means 5. Then we can have 6 sides. 1, 2, 3, 4, 5, 6. 6 sides. It is also a polygon. Its special name is Hexagon. Hex means 6. Okay. So a polygon starts with triangle, then quadrilateral, then pentagon, then hexagon. If 7 sides, okay. If 7 sides, then it is called heptagon. Hep means 7. If 8 sides, it is called octagon. OCT, oct means 8. Okay. If 9 sides, it is called nonagon. Here non means 9. Okay. If 10 sides, then also it is a polygon. Its special name is deca. Deca means 10. Okay. Nona means 8. Octa means nona means 9. Octa means 8. Okay. Hepta means 7. Hexa means 6. Penta means 5. Quad means 4. Okay. So these are some special types of polygons. Okay. Triangle, quadrilateral, etc. So remember this. The polygon having minimum number of sides is triangle. Okay. So don't think that triangle is different and polygon is different. Okay. Triangle is a special type of polygon. It can have more than a polygon can have more than 10 sides also. Okay. Now types of polygon. Okay, there are two types of polygon. One is convex polygon. Second is concave polygon. Okay. Now let us understand what is convex polygon. A convex polygon is a polygon in which each interior angle is less than 180 degree. Okay. So remember this. If each interior angle of a polygon is less than 180 degree, then it is called a convex polygon. For example, I am drawing a diagram. I have drawn a pentagon. We can see each angle. Okay. A, B, C, D, E. Each of the 5 angles is less than 180 degree. Okay. What is the measure I don't know, but I am sure that each of the angles is less than 180 degree. So it is a convex polygon. Now what is concave polygon? If at least one angle, okay, I repeat, if at least one angle is more than 180 degree, means reflex angle. Okay. If at least one angle is more than 180 degree or reflex angle, then it is called a concave polygon. For example, I have drawn a hexagon. As you can see, 1, 2, 3, 4, 5, 6. There are 6 sides, so it is a hexagon. But you can see angle A, angle B, angle C, angle E, and angle M. These angles are less than 180 degree, but angle B, this angle, the interior angle B, okay, the interior angle B is more than 180 degree. So such a polygon is called concave polygon. Okay, so this is convex and this is concave. This is not in your syllabus. Okay, so whenever the term polygon is used, you have to understand that it is convex polygon. If it would be concave, then it would be clearly mentioned in the question. Okay, unless mentioned, do not think that it is concave. Okay, always assume that it is convex. Now we move to sum of angles of a given polygon. Okay, let us take some examples of polygon. First we will start with triangle. What is the sum of angles of a triangle? 180 degree. You already know this. If we take a quadrilateral, okay, if we take a quadrilateral, we can divide a quadrilateral into 2 separate triangles. Okay, so these are 2 triangles. Sum of angles of this triangle is 180 degree. Sum of angles of this triangle is also 180 degree. So 180 plus 180 is 2 into 180. Okay. Now let us take a pentagon. Let us see how many separate triangles we can get from a pentagon. 1, 2 and 3. 3 separate triangles. So 180, 180, 180, 3 into 180. Okay. Next we move to hexagon. Let us see how many triangles you can get. Separate triangles. 1, 2 and 3. 1, 2, 3, 4. 4. Okay. So 4 into 180 degree. So in this way you can see there is a some relation with the number of sides. 3 sides, then 1 into 180. 180 means 1 into 180. Okay. 3 sides, then 1 into 180. 4 sides. What that means 4 sides? 4 then 2 into 180. 180 is constant. As you can see, 180 is constant. Simply 1, 2, 3, 4, 5, 6 like this it will go on increasing. 3 then 1. Okay. 3 then 1. 4 then 2 means 2 less. 3 1 2 less. 4 2 2 less. 5 3 2 less. 6 4 2 less. Okay. That means if a polygon has 15 sides, okay, if a polygon has 15 sides, then sum of its interior angles will be 13 into 180 degree, 2 less. If a polygon has 10 sides, the sum of its interior angles will be 10 minus 2, that is 8 into 180 degree. So from this we get a relation, we get a formula. If the number of angles of a polygon is n, okay, sorry, if the number of sides of a polygon is n, see here there are 6 sides, okay, there are 6 sides, here there will be 6 angles, 1, 2, 3, 4, 5, 6, 5 sides, 5 angles, 4 sides, 4 angles, 3 sides, 3 angles, okay. If a polygon has 15 sides, it will have 15 angles. Ready? So remember, if a polygon has n sides, sum of interior angles, sum of interior angles will be equal to n minus 2. Number of sides is n, so n minus 2 into 180. So this is the formula for sum of interior angles of a given polygon having n sides. Now let us move to exterior angles. Okay. Let us see what will be the sum of exterior angles. Is there any relation between sides and exterior angles? As there was relation between sides and interior angles. First, let us take a triangle. Now, first let us understand how to get exterior angle. Okay, if we produce the sides, then only we can get the exterior angles. Let us produce the sides in one order, in anti-clockwise order. Okay, AB has been produced, BC has been produced, CA has been produced. Okay, so these are the 3 exterior angles, 1, 2 and 3. There are 3 exterior angles. Ready? Suppose this exterior angle is x. Exterior angle at A is x. Exterior angle at B is y. Exterior angle at C is z. Okay, let us try to find x plus y plus z. X plus angle A, this angle, inside angle. X plus angle A will be 180 degree because they form a linear pair. Okay, so x plus angle A plus y plus angle B. Y plus angle B will also be 180 degree because they form a linear pair. Then Z plus angle C is equal to 180 plus 180 plus 180, that is 360 degree. Okay, sorry 540 degree. 180 plus 180 plus 180 is 540 degree. Now let us separate x, y and z, because our target is x plus y plus z. Then let us separate a, b and c. Okay, now what is angle a plus angle b plus angle c? It is 180 degree. So this is 180 degree. So I will take this right side. 540 minus 180, that is equal to 360 degree. So in case of a triangle, okay, in case of a triangle, sum of the external angles is equal to 360 degree. Okay. Now let us move to quadrilateral and check how much we are getting. Maybe it will increase, maybe we don't know. Suppose I am taking a quadrilateral. P, Q, R, S. Sum of its interior angles will be 360 degree. Okay, you know this from lower class. Also using formula n minus 2 into 180 degree. Here n is 4, so 4 minus 2 is 2. 2 into 180 is 360 degree. Okay, this is sum of interior angles, but our target is to find sum of exterior angles. We have to produce the sides. Let us produce the sides in anti-clockwise direction. PQ, then QR, then RS, then SP. Okay, I am producing one order. Let the external angles be A, B, C and D. Okay, A, B, C, D. My target is to find A plus B plus C plus D. Now see, what is A plus angle P? A plus angle P is 180 degree. This is 180. Linear here, straight line. Okay. Then B plus angle Q is also 180 degree. B plus angle Q is also 180 degree, linear pair. C plus angle R is also 180 degree. Then D plus angle S is also 180 degree. Okay, so 184 times 180, 180, 180, 180, 184 times is equal to 720 degree. Our target is A plus B plus C plus D. A plus B plus C plus D. A plus B plus C plus D plus. These have been separated. Now we will separate P, Q, R and S. Okay. So angle P plus angle Q plus angle R plus angle S is equal to 720 degree. A plus B plus C plus D plus. Now what is this? Angle P plus angle Q plus angle R plus angle S, sum of interior angles of a quadrilateral, which is 360 degree. Okay. So plus 360 degree is 720 degree. That means A plus B plus C plus D is equal to 720 minus 360, that is again 360 degree. No change. Okay. There was change in sum of interior angles, but you can see there is no change in the sum of exterior angles. So in case of triangle also sum of exterior angles was 360 degree. In case of quadrilateral also we got sum of extra angles is 360 degree. In case of pentagon also we get the same 360 degree. In case of any polygon, hexagon, heptagon, octagon, nonagon, decagon, 11 sides, 12 sides, any sides, any number of sides, always the sum of extra angles is always 360 degree. That you have to remember. Okay. So from this we conclude that for any polygon, the sum of exterior angles is 360 degree. Okay. The sum of exterior angles is 360 degree. This is for interior angles. This is for exterior angles. Okay. Remember this formula. Next, we will move to regular polygons. Okay. Now, what do you mean by regular polygon? Okay. A polygon is said to be regular if it satisfies two conditions. Remember this two conditions. The first condition is all sides are equal in length. Number two condition is all angles are equal, means all interior angles. I am talking about interior angles. Okay. Unless stated, we cannot take exterior angle. So for a polygon to be regular, two conditions have to be satisfied. First is all sides should be equal in length. Second is all angles should be equal. Okay. Then only we can say that the polygon is regular. Both the conditions have to be satisfied. Not one is not sufficient. Okay. So let us take some examples of regular polygons. First we will start from triangle. First we will start from triangle. All the sides must be equal. Okay. What type of triangle is this? If all the sides are equal and all the angles are equal, it is an equilateral triangle. Okay. It is an equilateral triangle. So, a polygon, a regular polygon, okay, a regular polygon having three sides is equilateral triangle. Okay. Now let us move to four sides. Can we say that rhombus is a regular polygon? In a rhombus, all the four sides are equal, but all the four angles are not equal. So rhombus is never a regular polygon. Remember this. Can we say that a rectangle is a regular polygon? No. Only the angles are equal, 90, 90, 90, 90. But the sides are not equal. All the sides are not equal. So rectangle is also not a regular polygon having four sides. So which quadrilateral or which polygon having four sides is regular? All the sides must be equal. All the angles must be equal. That means it is a square. So remember, a regular polygon having four sides is square. Okay. Similarly, we can go for five sides. My diagram is not accurate. Okay. All the sides must be equal. All the angles must be equal. Five sides in this pentagon, which is called regular pentagon. Similarly, six sides then regular hexagon. Seven sides then regular heptagon, regular octagon, regular nonagon, regular decagon. In this way it will continue. Okay. So these are some examples of regular polygon. So remember the conditions. A polygon is said to be regular only if it satisfies two conditions. What are the two conditions? First is all the sides must be equal in length. Second is all the angles must be equal. Okay. Now a polygon may be regular, may not be regular. Doesn't matter. Okay. A polygon may be regular, may not be regular. But the sum of interangles will be n minus 2 into 180 degree. N minus 2 into 180 degree. Ready? Now, if all the angles are equal, let us try to find the value of the interangles using some formula. If there are n sides in a polygon, there will be definitely n angles in the polygon. 3 sides, 3 angles. 4 sides, 4 angles. 5 sides, 5 angles. 7 sides, 7 angles. In this way, okay. If a polygon has n sides, then definitely it will have n angles. Okay. So sum of n equal angles is 180 degree. Sum of n equal angles is 180 degree. So what is the value of each angle or each interangle? You can use unitary method. Suppose cost of 10 pence is rupees 120. Then cost of 1 pen will be rupees 120 by 10. Okay. Similarly here, sum of n equal angles is n minus 2 into 180 degree. So each interior angle is equal to, using unitary method, n minus 2 into 180 degree by n. Remember this formula for regular polygon only. This formula can be used only for regular polygon. N minus 2 into 180 degree by n. Okay. Now let us go for each exterior angle. Same method. Okay. Sum of n exterior angles is 360 degree. We have studied a polygon may be regular, may not be regular, but sum of extra angles is always 360 degree. It doesn't change. So sum of n extra angles is 360 degree. N sides means n interior angles and n exterior angles. Okay. So each exterior angle is equal to, using unitary method, we get 360 degree by n. So remember this formula for each interior angle, for each exterior angle. Okay. Now let us move to some examples, problems. Then we will end the part 1. First exercise, exercise 14a. Exercise 14a. Question number 2. The angles of a pentagon are in the ratio 4:2. Number 2. The angles are in the ratio 4:8:6:4:5, and it is a pentagon, 5 sides, and is equal to 5. Find each angle of the pentagon. Each angle means interangle we have to find. Okay. Ratio is given, so let us take a variable. Let the angles be 4x, 8x, 6x, 4x and 5x. Okay. Now let us take sum of the angles. 4x plus 8x plus 6x plus 4x plus 5x is equal to, sum of angles formula is n minus 2 into 180 degree. Here n is 5, so 5 minus 2 into 180 degree. 5 minus 2 into 180 degree. Okay, using the formula. Add all this. 27x is equal to 3 into 180 degree. X is equal to 3 into 180 degree by 27. 3 9 is 27, 9 20. Okay, that means the value of x is 20 degree. Once we get the value of x, we can find each interior angle. Okay. So the first angle is, okay, the first angle is x we put 20. Okay. First angle is equal to 4x. So 4 into 20, that is equal to 80 degree. I have not given any name. You can give name. Angle A, angle B, angle C, angle D, angle D. 5 sides, 5 angles. Okay. If you want, you can give names. Second angle is equal to 8x. So 8 into 20. 8 into 20, that is equal to 160 degree. Okay. Third angle is equal to 6x. 6 into 20, 120 degree. Fourth angle is equal to 4x. 4 into 20, 80 degree. Okay. Last angle or the fifth angle is 5x. 100 degree. Okay. This was one example, example number 2 or question number 2. Now let's move to question number 5. Three angles of a seven-sided polygon. Number 5. N is 7 given, seven-sided polygon. Three angles are 132 degree each. Okay, there are three angles of the polygon which are 132 degree each. And the remaining four angles are equal. Okay, let the remaining four angles be x degree each. Okay. Three angles are 132 degree each. Let the remaining, how many remaining angles will be there? 7 sides means 7 angles. Out of 7, 3 angles are 132 degree each. So definitely 4 angles will be remaining. So let the remaining 4 angles be x degree each. Okay. Now let us take the sum of the angles. So x plus x plus x plus x plus 4 angles, x plus x plus x plus x. 132 degree 3 angles are there. So 132 plus 132 plus 132 is equal to, total sum of angles will be n minus 2 into 180. What is n here? 7. So 7 minus 2 into 180 degree. This is 4x. This is 3 into 132. Okay, 3 times. 3 into 132 is 396 degree is 7 minus 2 is 5. 5 into 180 is 900 degree. So 4x is equal to 900 minus 396, that is equal to 504 degree. 504 degree. So x is equal to 504 by 4, which is equal to 1 to 6 degree. So value of each of the remaining 4 angles is 126 degree. Okay. Move to example 7. In a pentagon ABCDE, AB is parallel to DC. So you have to draw the figure. Example 7. Okay. AB is parallel to DC. Suppose this is AB. ABCD. CDE. I have taken two parallel sides, AB parallel to DC according to the question. Okay, AB parallel to DC. Angle A is to angle E is to angle D. Okay, angle A is to angle E is to angle D is given 3 is to 4 is to 5. Okay, so let angle A be 3x, let angle E be 4x, let angle B be 5x. So angle A is 3x, angle E is 4x, angle D is 5x. We have been asked to find angle E. Our target is angle E. What is angle E? 4x. So anyhow we have to find x. Once we get x, we can easily get angle E. Okay, our target is our target is x. Now let us take the sum of the angles. Angle A plus angle B plus angle C plus angle D plus angle E is 5 sides, 5 angles. Okay, 5 angles means n is 5. So sum of angles will be n minus 2 into 180. N minus 2 into 180 means for this case 5 minus 2 into 180. Now angle A, angle B and angle E. These three values we have, means values we have not got, but in terms of x we have got. So 3x plus B and C I will put later on. Okay, let us go for D and E. D is 5x, E is 4x. Now let us see what is angle B plus angle C. No relation has been given. Okay, B and C, nothing has been given about B and C. But you can see B and C are allied angles or co-interior angles. Okay, see AB parallel to DC and these two angles are in between the two parallels. So definitely sum of these two angles will be 180 degree. Sum of co-interior angles is always 180 degree. Okay. So in place of B plus C, we can put 180 degree, and this is 5 minus 2 is 3. 3 into 180 is 540 degree. We'll give the reason. Allied angles. Allied angles means co-interior angles. For this, b plus c. Remaining values were given. Okay. Now 3x plus 5x plus 4x is equal to 12x. This is 12x. Now 540 minus 180 is equal to 360 degree. X equal to 360 by 12 is equal to 30 degree. Once you get x, you will get angle E. We can find angle A and B also. But we have been asked to find angle E. So what is angle E? 4x. 4x means 4 into 30, that is equal to 120 degree. Okay. Now let us move to the last example of this part. Same exercise 14a. Question number 10. Question number 10. The difference between an exterior angle of n minus 1 sided regular polygon. Okay. Number 10. The first regular polygon has n minus 1 side. Okay, n minus 1 sides. And it is the regular polygon. And an exterior angle of n plus 2 sided regular polygon. There is another regular polygon which is n plus 2 sides. Okay. And the difference between each exterior angle will be equal because it is regular polygon. Okay. The difference between each exterior angle is 6 degree. Okay. Difference is given 6 degree. Find the value of n. Now for regular polygon, this is about extra angle, so we will move to extra angle. Okay, don't think of interior angle, that is n minus 2 into 180, forget it now. Okay, we don't have any work with interior angle. Okay, so let us move to exterior angle. Sum of extra angle is 360 degree for any polygon. Okay, now the first polygon, it is a regular polygon and it has n minus 1 sides. So what will be the value of each extra angle? If a regular polygon has n sides, then each extra angle is equal to 360 degree by n by formula. 360 degree by n, I have shown it. Okay, a few minutes before. Okay, so each extra angle is equal to 360 degree by n for a regular polygon having n sides. Similarly, for a regular polygon having n minus 1 sides, what will be the value of each extra angle? Obviously 360 degree by n minus 1. Similarly, what will be the value of each extra angle for a regular polygon having n plus 2 sides? If n sides, then 360 by n. If n minus 1, then 360 by n minus 1. If n plus 2, then 360 by n plus 2. And the difference is given 6. Okay, this was given. The difference between the extra angle is given 6 degree. So now let us solve this. LCM you have to take n minus 1 n plus 2. Ready? N plus 2 will be multiplied with 360. 360 whole n plus 2 minus 360 whole n minus 1. Is 6. Okay, so 360 whole n plus 2 minus 360 whole n minus 1 whole by n minus 2 into n plus 2 is equal, n minus 1 into n plus 2 is equal to 6. Now let us solve this. Open the bracket. 360n plus 720 minus, be careful, whenever you see minus, then be careful. Minus 360 into plus n is equal to minus 360n. Minus 360 into minus 1 is equal to plus 360. Okay. Now let us expand the denominator. N into n plus 2 will be n square plus 2n. Minus 1 into n plus 2 will be minus n minus 2, which is 6. Okay, we can cancel 360n and 360n. So 720 plus 360 is equal to 1080. Then this is n square plus 12 minus n is n square plus n minus 2 is 6. 1080 is equal to 6 whole n square plus n minus 2. Okay. Let us divide each side, means both sides, by 6, or bring this 6 to the left. Okay. So we will get dividing by 6, 180 is equal to n square plus n minus 2. It is clearly a quadratic equation. Let us take this 180 to the right. 0 is equal to n square plus n minus 2 minus 180 is equal to minus 182. Okay. So we have to solve this quadratic equation. You have already studied the chapter factorization. Using that concept, you have to solve this. Okay. 1 minus 182. Okay. 1 minus 182. I am writing the coefficients. 1 minus 182. First into last is minus 182, which is negative. Negative means difference. Okay, I have already explained this in factorization. So think of two numbers which product will be 182. Okay, and difference, negative means difference, product will be 182 and difference will be 1. Means you have to think of two consecutive numbers. Okay, so let us try and factorize this. 2 9 are 18, 2 1 are 2, 2 7 and 13. You can see 2 7 are 14 and 13. So 13 into 14 is 182, and difference between 14 and 13 is 1. So you can take these two numbers, 14 and 13. So n square, we need plus n, means 14 minus 13. 14n minus 13n minus 182 is 0. n whole n plus 14 minus 13 whole into n plus 14 is 0. There are two terms, n plus 14 can be taken common. So remaining is n minus 13. N plus 14 is 0 or n minus 13 is 0. N is minus 14 or n is 13. 13 can be accepted. Minus 14 cannot be the number of sides. Number of sides cannot be negative. So this minus 14 is discarded. So what is the value of n that can be accepted? 13. Okay. So I hope you have understood this part 1 related to polygons. Okay. So in the next part we will start quadrilaterals, special types of quadrilaterals. Okay. Thank you for watching.